The question of what existed before the Big Bang and the immense influence that it has had is a topic that has sparked intense debate among scientists for a long time. This fascinating subject challenges not only our understanding of the universe, but also the limits of human knowledge. Imagine standing at the threshold of existence, peering into the vast unknown, and contemplating what could have been present before the birth of our universe, before the Big Bang, often regarded as the origin of time and space itself. The very concept of this moment raises questions about a time that might have existed before, a state of nothingness, a calm before the explosion of chaos. As we dive deeper into this question, science pushes us to explore realms beyond our current understanding, forcing us to reconsider our perceptions of the universe. Could there have been something even more puzzling existing before time itself? To explore this, we turn to experts like physicist Brian Cox, who challenges our thinking by suggesting that something remarkable may have preceded the Big Bang. His work invites us to rethink everything we know about dark energy, quantum fluctuations, and even the idea of a multiverse. Get ready for a journey into the heart of the cosmos, where the answers we uncover may be as unsettling as they are enlightening. Before we can delve into what may have existed before the Big Bang, it's crucial to understand what the Big Bang itself represents. According to scientists, the Big Bang marks the moment when the universe suddenly became intensely hot and dense, rapidly expanding and giving birth to all the matter, energy, and forces that govern the universe. The night sky stands as evidence of this fiery origin, where galaxies stretch far beyond our imagination and the darkness still wraps around the cosmos, leaving scientists both bewildered and captivated. But what caused this massive explosion of energy? The theory of cosmic inflation provides some insight, suggesting that before the Big Bang, the universe existed in an empty, tranquil state, too serene to be the hot, dense beginning we know. However, this vacuum wasn't entirely empty. It contained a vast amount of energy that fueled the rapid expansion of space, known as inflation. This process occurred so quickly that it resolved many of the issues surrounding the universe's early development. Eventually, this energy transformed into matter, particles, and forces during the Big Bang. But what was the nature of this energy? And why did the universe suddenly begin to expand? One theory that attempts to explain this involves the concept of inflationary theory, which posits that each region of space could go through its own version of the Big Bang, creating a patchwork universe. According to this theory, our universe could simply be one of many in an infinite multiverse, where countless other universes, each with its own Big Bang, exist. This idea challenges our traditional understanding of the universe, raising the possibility of a never-ending array of universes. In terms of nothingness, scientists argue that the idea of an absolute void before the Big Bang is speculative. Even if all particles and radiation were removed from the universe, it wouldn't truly be empty. Dark matter and energy still pervade the universe, and even in its most incomplete form, the cosmos remains filled with quantum fields and forces that we don't fully understand. This leads researchers to question whether true emptiness is even possible. If we were to imagine a void, devoid of matter, radiation, and even negative energy, we would still be left with quantum fields, constants, and other forces. These forces would create a dynamic environment where particles could appear and disappear, challenging our definition of nothingness. This raises the possibility that something was always present, even before the Big Bang, and suggests that our understanding of the cosmos is far from complete. One intriguing concept in modern cosmology is the idea of an eternal universe, one that continues to evolve endlessly through cycles of birth, death, and rebirth. This cyclic cosmology theory suggests that the Big Bang may not have been a singular event, but part of an ongoing process of universe creation and renewal. In this view, the universe could have gone through multiple iterations, each one emerging from the remnants of the previous cycle. If this theory holds true, it implies that the universe has no true beginning but instead exists in a continuous cycle beyond our current comprehension of time. Another fascinating theory that could shed light on what happened before the Big Bang is the study of gravitational waves. These waves, first detected in 2015, are ripples in space-time caused by massive cosmic events like black hole mergers or neutron-star collisions. Some physicists believe that gravitational waves from the early universe may offer clues about the state of the cosmos before the Big Bang, potentially revealing whether the Big Bang was truly the beginning of everything or if cosmic events predated it. As we investigate these theories, we are confronted with the possibility that our universe might be just one piece of a much larger, more complex cosmic web, a web of endless universes, each born from the ashes of the one before it. Whether or not we ever find definitive answers to the questions of existence before the Big Bang, these ideas open up new vistas for understanding our place in the vastness of the cosmos. Imagine a trampoline stretched taut, and then a heavy object dropped onto it. The fabric sags, bending and curving. If the weight is heavy enough, it could create a depression so deep that everything nearby might be drawn into it. This is a simple metaphor for what might happen in the Large Hadron Collider, LHC, where the bizarre and beautiful laws of quantum physics govern our universe. Some scientists theorize that hidden dimensions could lie within our reality, and, if these dimensions exist, the LHC's collisions could potentially tap into them, creating a gravitational funnel that could form a microscopic black hole. This mysterious particle dance has captured the attention of renowned scientists, including the late Stephen Hawking. In his writings, Hawking warned of the possibility that the Higgs boson might become unstable at high energy levels. Such instability, he suggested, could lead to a catastrophic vacuum decay, an event capable of destroying not only Earth but the entire universe. Sir Martin Rees, the distinguished British cosmologist and astrophysicist, also voiced concerns about CERN's experiments in his book On the Future Prospects for Humanity. He examined the risks associated with particle accelerators, highlighting the potential for disaster not as a far-off, improbable event, but as something that could happen through an unfortunate experiment. According to Rees, such an event could trigger a vacuum instability that could lead to a phase transition, unraveling the very fabric of space-time and causing a cosmic catastrophe that could engulf the universe. Rees went on to assign a probability to this apocalyptic outcome. While he acknowledged the risk was low, he argued that even a slim chance warranted serious reflection. The stakes, in his view, were astronomical, and the margin for error was perilously small. The scientists at CERN, however, have conducted calculations, simulations, and exhaustive reviews to assert that the LHC's operations are safe. Brian Cox, for one, has acknowledged the concerns surrounding the LHC, but reassured the public that rigorous safety protocols are in place. He emphasized that the energies involved in the collider's experiments are well within the range that the Earth naturally experiences, and the chances of creating a stable black hole are virtually non-existent. Even if such a black hole were to form, Cox explained, it would be so small and unstable that it would quickly evaporate due to Hawking radiation, an event predicted by Hawking himself. It would be a brief, fleeting cosmic spectacle, and then it would vanish. Some individuals have even speculated that the LHC might open a portal to another universe or dimension. While this idea has largely been dismissed by scientists, it continues to capture the imagination of many. It has given rise to fears, fascination, and even folklore, leading to sensationalized media portrayals of potentially opening a gateway to hell. But where did this notion come from, and how does it relate to scientific exploration? The idea of parallel dimensions is not new to physics. String theory, a leading candidate for a unified theory of everything, proposes that there could be more than the familiar three dimensions of space and one of time. These extra dimensions may be compactified or hidden from view, but under extreme conditions they could theoretically be revealed. The LHC in this context could be seen as a cosmic key, unlocking doors that have remained sealed since the beginning of time. If protons collide at energies previously unattainable on Earth, they could, in theory, create ripples or tears in the fabric of space-time, possibly opening temporary portals to these hidden realms. Although much of this remains speculative, the possibility is nonetheless compelling. The central question, however, is one of responsibility. Should we be manipulating forces that could fundamentally alter the very fabric of reality itself? With the LHC's ability to probe the deepest corners of existence, should we be concerned about what we might uncover? As Brian Cox and other scientists continue to delve into the universe's mysteries, one thing is clear: the pursuit of knowledge comes with its risks. Unveiling the unknown, especially at the LHC, is a journey fraught with both visible and invisible dangers. The story of the LHC is more than just a tale of cutting-edge science. It represents humanity's insatiable thirst for understanding. Every experiment and discovery brings us closer to revealing the universe's complexities. But the crucial question remains: when we unlock the deepest secrets of the cosmos, are we prepared for the consequences? Or will we, like Anatoly Gorsky, find ourselves at the edge of the unknown, gazing into a universe we may not fully understand or control? The answer lies in the future, one filled with both potential and peril. As we stand on the precipice of discovery, we must ask ourselves, are we truly ready to face what we might unleash?